7th grade Open Up Resources Illustrative Mathematics, Unit 4, Lesson 15, Error Intervals. Problem number 1. Jada measured the height of a plant in a science experiment and finds that, to the nearest quarter of an inch, it is 4 3/4 inches. A. What is the largest the actual height the plant could be? When Jada measured the plant, she found that it was 4 3/4 inches tall. And the information tells us that this measurement could be within the nearest quarter of an inch. That means that her measurement of 4 3/4 inches could be accurate within a quarter of an inch. A quarter of an inch is also equivalent to 2/8 of an inch. We can rewrite 4 3/4 as 4 6/8. The height of this plant could possibly be 1/8 taller than 4 6/8 or 1/8 shorter than 4 6/8. So the tallest the height of this plant can be would be 4 6/8 plus 1/8 or 4 7/8 inches tall. Now that we've answered A and determined that the tallest the plant could be is 4 7/8 inches tall, let's answer B. What is the smallest the actual height of the plant could be? Remember, Jada's measurement was 4 3/4 inches or 4 6/8 inches. To find the shortest height this plant could be, we'd have to subtract 1/8 from 4 6/8. So 4 6/8 inches minus 1/8 of an inch equals 4 5/8 inches. The smallest or the shortest this plant could be would be 4 5/8 inches tall. C. How large could the percent error in Jada's measurement be? 1/8 divided by 4 3/4. That'll tell us how large the percent error would be. We can do this using decimals. 1/8 is equivalent to 0.125 divided by the decimal equivalent of 4 3/4, which is 4.75. This is approximately 0.026, and to write this as a percent, it would be approximately 2.6%. That means that the largest the percent error could be in Jada's measurement would be 2.6%. Problem number 2 from 7th grade Unit 2, Lesson 5. Water is running into a bathtub at a constant rate. After 2 minutes, the tub is filled with 2.5 gallons of water. Write 2 equations for this proportional relationship. Use W for the amount of water in gallons and T for time in minutes. In each case, what does the constant of proportionality tell you about the situation? The first equation is W equals 1.25 T. This means every minute the amount of water increases by 1.25 gallons. The second equation is T equals 0.8 W. This means every 8/10 of a minute the amount of water increases by 1 gallon. Problem number 3 from 7th grade Unit 4, Lesson 5. Noah picked 3 kilograms of cherries. Jada picked half as many cherries as Noah. How many total kilograms of cherries did Jada and Noah pick? Let me explain why I chose expression C. First, look inside the parentheses. You have a 1 plus 0.5. That's like 1 plus a half. And it says here that Jada picked half as many cherries as Noah. So the 1 represents Noah, and the 0.5 represents the amount of cherries that Jada picked. The information also tells us that Noah picked 3 kilograms of cherries. Look outside the parentheses where it says times 3. 3 times 1, or the amount that Noah picked, equals 3. So 3 times the amount Noah picked equals 3 kilograms. And 3 times 0.5, or 3 times the amount of cherries that Jada picked, equals 1.5. Since half of 3 kilograms is 1.5 kilograms, and the information tells us that Jada picked half as many cherries as Noah, I know that expression C matches the story. Problem number 4. The reading on a car's speedometer has 1.6% maximum error. The speed limit on a road is 65 miles per hour. A. The speedometer reads 64 miles per hour. Is it possible that the car is going over the speed limit? We need to multiply 64 times 1.6%. Remember, 1.6% as a decimal is written as 0.016. So let's multiply 64 times 0.016. That's equal to 1.024. Now let's add that maximum error to 64. 64 plus 1.024. That's equal to 65.024. So yes, it is possible that the car is actually driving over the speed limit. B. The speedometer reads 66 miles per hour. Is the car definitely going over the speed limit? 66 times 1.6%, that can be written as 66 times 0.016, and that equals 1.056. Let's subtract 1.056 from 66. That's 64.944 miles per hour, which is actually under the 65 mile per hour speed limit. So the answer to B is no. The car is not definitely going over the speed limit because it is possible that it's traveling at less than 65 miles per hour. Problem number 5 from 7th grade Unit 3 Lesson 7. Here's a shape with some measurements in centimeters. A. Complete the table showing the area of different scaled copies of the triangle. The formula for finding the area of a triangle is half of the base times the height. It's also half of the height times the base. For example, the area of this triangle would be half of 2 times 3. Since 2 times 3 is 6 and half of 6 is 3, the area of this triangle is 3 centimeters squared. With a scale factor of 2, the height times the base would be 4 times 6. Since 4 times 6 is 24 and half of 24 is 12, the area of the triangle with a scale factor of 2 would be 12 centimeters squared. With a scale factor of 5, the height would be 10 and the base would be 15. Since 10 times 15 is 150 and half of 150 is 75, the area of the triangle with a scale factor of 5 would be 75 centimeters squared. With a scale factor of s, the height would be 2 times s and the base would be 3 times s. 2s times 3s is 6s squared, and half of 6s squared is 3s squared. So the area of a triangle with a scale factor of s would be 3s centimeters squared. B. Is the relationship between the scale factor and the area of the scaled copy proportional? As you can see here, you have to multiply each of the scale factors by a different number to find the triangle's area. So the answer is no. The relationship between the scale factor and the area of the scaled copy is not proportional. Be sure to support my YouTube channel by liking this video, leaving a comment, and subscribing to my channel. Thanks for watching, and I'll see you next time.